Welcome to episode 55 of FTCE Seminar, a teacher certification podcast. Today we will be comparing the slopes of two linear functions represented algebraically or graphically to help you prepare for the FTCE General Knowledge Mathematics subtest. Concept 1, the slopes of two linear functions. Today we're entering the arena of linear functions, exploring how to compare the steepness of two lines both algebraically, that means using equations, and graphically. But what exactly is slope, and why is it important to compare the slopes of two linear functions? Okay. Imagine a ramp. The steeper the ramp, the more incline it has. Slope in the world of linear equations is like incline. It tells you the rate of change or how quickly the y value output changes as the x value input increases. So a steeper slope means the line goes up or down more dramatically. And that's one way to visualize slope. Now, let's say we have two linear equations in slope-intercept form, which is y equals mx plus b, where m equals the slope and b equals the y-intercept. Okay, two equations. Equation number 1 is y equals 2x plus 1. And equation 2 is y equals x minus 3. Let me ask you this. How can we compare the slopes algebraically? Like, do we need to solve for something? Nuh-uh. The key to interpreting these equations is the coefficient of our x term, meaning the number multiplying the x. This number represents the slope. Okay, stay with me now. This is so cool. Let's go back to our equations. In equation 1, y equals 2x plus 1, where the slope is 2 because 2 is the coefficient of x. But what about equation 2? Equation 2 states y equals x minus 3. So what is the coefficient of x? Think about it, but not too long. Did you get 1? You are so correct. The slope is 1 because the coefficient of x is 1. Translation, the slope of the first equation is 2, and the slope of the second equation is 1. Therefore, we can say that the slope of equation 1, y equals 2x plus 1, is steeper than the slope of equation 2, y equals x minus 3, because 2 is greater than 1. Okay, that makes sense. It kind of didn't make sense before, but now it does. But what if we only have graphs and not equations? Graphs but not equations? That's a great question. When we have graphs, we can visually compare the slopes. Think about it this way. We describe the slope of a line by its steepness and the direction, for example. Is the line dramatically slanted? And in what direction? Is it upwards or downwards? Does it go to the right or the left? So the line that looks more diagonal must have a steeper slope? You got it. Imagine placing the graphs side by side. The line that makes a sharper angle with the horizontal axis, the x-axis, has a steeper slope. Let's define this further. Imagine again that you're looking at the graph. A positive slope is a line that slants right, meaning upward from the left to the right, like you're going up a hill. A negative slope is a line that slants left, meaning downward from the left to the right, like you're going down a hill. Lastly, when it's a slope of 0, then it's a horizontal line. And here's something so cool. The slope of a vertical line is called undefined. So there you have it. Slopes can be described as positive, negative, 0, or undefined. Got it? Good. One more thing. I want you to understand rise over run, since we're talking about slopes and steepness and direction of the line. The rise over run formula is a way to calculate the slope of a straight line. But because, remember, slope tells us how steep the line is and in which direction it slants. Well, here's how it works. Rise. This refers to the vertical change between 2 points on the line. If you move up on the graph, that's a positive rise. If you move down, it's a negative rise. Run. This refers to the horizontal change between 2 points. Moving to the right is a positive run, and moving to the left is a negative run. The formula is pretty straightforward. It's m equals y2 minus y1 over x2 minus x1, where m represents the slope of the line, but we knew that, and y2 minus y1 represents the difference between the y coordinates of your 2 points. Remember, this considers if the change is positive or negative, and x2 minus x1, this is the difference between the x coordinates of 2 points. Again, considered positive or negative movement. Basically, you're taking the change in the vertical direction, rise, over the change in the horizontal direction, run. For example, if a line goes up 4 units, rise, and then moves 3 units to the right, run, the slope would be 4 over 3. This means the line slants upward as you move to the right. Oh, wow. Man, you did awesome today. Thanks for hanging in there. For more practice with math strategies, visit FTCEseminar.com to study for the test. The important thing is to start studying today so you can pass your teacher certification exam. What are you waiting for? Check us out on YouTube at FTCE Seminar and start studying today. This podcast was recorded at the Pickens Multimedia Studio at the University of West Florida. This podcast is listener supported. Contributions can be made via the listener support link on Spotify, or you can buy me a coffee at FTCE Seminar. This is your host, Mercedes Musto. Join me again on FTCE Seminar, a teacher certification podcast, so you can pass the FTCE.